Um, okay, great. So nice to meet you all. I'm Brent Stevens. I'm a professor and department chair here in the Department of Civil, Architectural, and Environmental Engineering. Um, I've been here since 2012. I've been what's called the department chair since 2018. So I can kind of speak to all of the ranges of our programs. I have a bachelor's in civil engineering. I have a master's in environmental engineering, and then my PhD was in the area of architectural engineering. So I can kind of tell you, all about um, each one of these domains. And I think before we get started, I'll just mention too that if you're not from the city of Chicago, I have absolutely loved it here. I actually applied to IIT for grad school and wanted to come here anyway. And then uh, ended up, they didn't have any like funding for grad school at the time. So I went to the University of Texas at Austin, huge school, 50,000, body campus. I really enjoyed it there. I spent 5 years there getting my master's and PhD. But as soon as this job opened up, as I was finishing up, I was super excited to apply for it, and I've never looked back. So I've been here ever since, coming straight out of my PhD. So I've kind of experienced in my undergrad like a small public tech school, Tennessee Tech University, which I'm from Tennessee. I've experienced like this huge football game day Saturday, University of Texas, 50,000 person campus. And then I've experienced our niche campus, which is several thousand, just in the shadow of downtown, kind of this urban campus that doesn't feel very urban, as you can tell from the picture of our building here. It's kind of this idyllic place. So anyway, I've really enjoyed it here, and I can tell you a little bit about our majors, but also answer questions that you might have about living and working in the city. It looks like, thank you guys for the poll. It's like half and half, half in-state, half outstate, and some international. So great, awesome. Thank you for doing that. That was great. All right, let's get rolling here. So regardless of what major you go into in our department of CAE, Civil Architectural and Environmental Engineering, you would learn to sort of focus on creating and maintaining infrastructure, right? So whether it's transportation systems or water systems or energy systems or communication systems or buildings, we do a lot in buildings. All of these are like critical components of infrastructure that make up our daily lives, right? And that affect our daily lives. And so we sort of operate with these overarching principles that infrastructure should be designed to protect human and environmental health, to use resources wisely. We don't always do that. We haven't done that for a long time. We're trying to fix that. That's your generation's problem to fix, right? And then hopefully improve the quality of life. That's the idea. And then interestingly, we work in both the public and the private sector, which is a little bit different from um, other types of engineering. There's a lot of us that go into the public sector, but you can do both. So the undergrad degrees that we offer here in CAE at Illinois Tech are a Bachelor's of Science in Civil Engineering, which is essentially you get exposed to all types of infrastructure. Transportation systems, water systems, structural systems, construction, how you build buildings on time, how you build infrastructure projects, and so on. We also have a Bachelor's of Science in Architectural Engineering, which some of you might not have ever heard of, but it's kind of a subset of civil, but it's branched into its own thing. So this is just if you're purely focused on buildings, but you're good at math and science and physics, and you're interested in buildings and their systems, then that architectural engineering may very well be for you. We also have a Bachelor's of Science in Engineering Management, which is kind of like a hybrid business and engineering degree that some of our students go into. And so within civil engineering, but also architectural engineering, at the core, no pun intended, is structural engineering. So whether you're dealing with subsurface foundation, bridges, and everything in between, like the building I showed on the first slide, structural engineering prepares you to focus on this. So you get exposed on in the civil and architectural engineering degrees to structural engineering. So you learn the fundamentals of structural analysis and design. So you can apply them to steel, concrete, or timber frame structures, including tall buildings, towers, bridges, dams, retaining walls, foundations, even stadiums, and so on. So our largest number of faculty are actually in the area of structures, kind of spanning a wide range of experiences. That's our historical core, but we do other things too. Civil engineering also includes transportation engineering. um, that is, at its core, it's designing and analyzing transportation systems and their components, highways, railways, airports, road networks, traffic control systems as well. I don't know why I put parking lots on here. That's probably the most boring thing I could think of. But it's a job that needs to get done. You might start out your career early doing parking lot design and then move on to more interesting things. It happens. Traffic control systems gets into a lot of complexity. Here's this kind of video, this screenshot of a Chicago traffic simulator up here that our main professor in this area, Dr. Lee, um, has developed with his students over the years. So you can simulate like how people will move about the city under different situations. We also have a really busy and active railroad club here that I'll tell you about in just a little bit. So transportation is another area of civil engineering. Across civil engineering, we also have construction engineering and management. You also get exposed to this in architectural engineering too. We have two main faculty members there, Professor Arditi and Mudis. Their goal is to manage quality control and ensure a project is completed on time and on budget. So it's engineering, but it's with a focus on management of construction projects. So you have to learn about construction equipment, construction scheduling and planning. Imagine how much coordination it takes to schedule, like, building a giant water treatment plant or wastewater treatment plant or building an airport. It's a tremendous amount, right? So there's a lot of complexity. There's also kind of this emerging area of IT in construction. So I don't think I have this in the slides, but we just received a big gift from a company called Trimble to build Trimble Technology Lab, where you would get a chance to essentially, this just happened in the last few months, where you would get a chance to sort of try out virtual reality in construction projects. And there's a number of like 3D imaging type of hardware and software where you can go and take pictures, if you will, take 3D scans of a building or some construction project or whatever, and kind of convert those back into technical drawings at a 3D or 2D level, which is really, really cool stuff. So we're just I think the second university in the country to be awarded this major gift of a Trimble Technology Lab. So it's really special and just coming online. Oh, you guys don't need to be there. Sorry about that. Civil engineering also includes, as a subset for us, environmental engineering. We've got 3 faculty members full-time who work in this area, but environmental engineers protect human health in the environment by providing drinking water treatment, wastewater treatment, air pollution control, water resources management, and even dealing with industrial or hazardous waste. So you learn the fundamentals and principles here. And we've got the huge market in Chicago. In fact, the Stickney wastewater treatment plant, run by the Metropolitan Water Reclamation District, is the largest wastewater treatment plant in the world. And it's just kind of down the road, not so close that you can smell it, but down the road 10 miles or something like that. So it's kind of in our own backyard, and we've got a lot of alumni that work here. And then finally, moving out of civil engineering and into architectural engineering. If you're not familiar with this, architectural engineers, like I said, focus on buildings. We collaborate with architects and civil engineers to build structures that really, to build buildings that consider energy use, environmental impacts, human health, economics, and sustainability. So if you're into, the idea of green buildings and making buildings healthier and more energy efficient spaces, then architectural engineering might be for you. There's a lot within architectural engineering to learn about not only the structural systems of the building, but the performance of the envelope, the facade. You guys might recognize this Aqua Tower building here in Chicago. It's sort of famous for its architecture and also sort of infamous for not being very energy efficient for some of these little fins here. So I don't know, we study these things. So ideally we work with architects to make buildings as best as they can be. So we've got 4 main faculty here, but we also leverage all those other faculty that were listed in structures and construction especially. So just a few notes on both of these programs. For both of them, accreditation and licensure is really important. So our civil engineering and our architectural engineering programs are both accredited by ABAT, which is this accrediting body. The most important piece for you is that if you are to become a civil or an architectural or environmental engineer, You are essentially starting your journey to becoming a professional, registered or licensed professional engineer. This is really important for whether you're a structural designer or water treatment plant designer or an air pollution control engineer or anything in that domain, mechanical system designer in buildings. At some level, you have to demonstrate that you've got professional competence and you put your license on the line when you approve a design that you and your firm have worked on. And you say, this thing is going to hold up. This thing is not going to fall down. This thing is not going to fail, and so on and so forth. By doing so, you've got to be a licensed professional engineer. And carry with that professionalism and ethics and everything that comes with that. And so to start there, you have to have an ABET accredited degree. So our civil and architectural engineering programs are both accredited. Illinois Tech is one of only about 25, I think, ABET accredited architectural engineering programs. And then the civil engineering, there's hundreds of those across the U.S. Engineering management is kind of a hybrid, is not ABET accredited. So it's really more for people who are like, well, I don't think I need to be a professional engineer. I kind of want to exist in the intersection between engineering and business. I will just mention a few key features. I don't think this is comprehensive, but one of the things that I've seen a lot of our students move into in the last few years is our co-terminal degrees or our accelerated master's degrees. So what happens with these, if you haven't heard much about them, is they're essentially like 5-year bachelor's plus master's programs combined. We have existing pairings. For example, you could do a bachelor's in civil engineering and then a master's in environmental engineering or structural engineering or transportation engineering. Our master's programs are focused, like they're discipline specific. They're not just like civil engineering. They're like environmental, structural, construction, transportation, and so on. So these already exist. The good thing here is you get to share 3 courses between your undergrad and your grad. So it really is kind of a fast track to a master's. Another good thing is whatever financial aid and scholarships you receive for your undergrad continue into this 5th year. So last time I checked about a year ago, something like 20 to 25% of our undergrad students were following this pathway as a fast track master. And then we also have initiated something where you can mix and match your own. So you can go take other masters outside of our discipline, and other bachelors from outside our discipline can come to us. So these mix and match kind of variety pairings are really useful. So that's something I think that I see a lot of our best students doing. And they do it in part because there they are in their junior year and kind of being exposed to all the aspects of the discipline, civil engineering, architectural engineering, construction, transportation, structures, all of that together. And then finally, by the time you get into your 3rd and 4th year, you realize, oh my gosh, I really do like architectural engineering, but I don't like structural engineering. I don't want to do that. But what I do really like is kind of the building systems, mechanical, electrical, and plumbing. That's really great. And I see that there's a bunch of courses that this school offers to get a master's in that area. So let me do that. And that way I come out specialized and can compete with other people that are coming out with a 4 or 5-year degree as well at kind of a higher level. So I see a lot of people doing that. How's the job outlook for civil environmental engineers and architectural engineers? I always like to say that you don't go into civil and environmental and architectural engineering for the money. You go into them to make an impact and to have like a tangible impact on the world and your local and or national society. But you also do make money reasonably well, in doing so. And so that combination of like making good money, but not often great money, unless you start a construction firm or something like that, you can make a lot of money. But also feeling good and doing good with your job consistently puts civil and environmental engineers in kind of the top of the list of best engineering jobs from places like US News and World Reports. Architectural engineering is funny. There's less data out there because there are very few professional titles where you say, I am an architectural engineer at such and such company. Instead, you're often an architectural engineer who then becomes a structural engineer in a firm or a mechanical engineer I'm writing too fast to make that legible. Or even an electrical engineer, not an electrical engineer who works on iPhones and stuff like that, but an electrical engineer who works on electrical systems and buildings. And so it's hard to kind of capture all of that because if you go search for architectural engineering jobs, it can be hard to find it. But if you search for structural or mechanical or electrical and buildings, you can find all of the job opportunities. But USA Today, about 2 years ago, did um, a survey of college majors with the lowest unemployment, and architectural engineering was in the top 15 with a really low unemployment rate and a good average salary. So again, across CAE, make good money, but also do good. I want to mention another highlight of our of what that I see here at Illinois Tech. Again, coming from the experiences that I've had, from literally the first day that I stepped foot on campus, one of the things that stood out to me is that our students are extraordinary. And for a small school, I think we pack like a lot of punch. We punch above our weight, if you will, in that we have a lot of student organizations, and they all have capacity to absorb new students. They all have capacity for new students to take on leadership roles. And so they're really mature and they're really professional, our students on average, more so, I think, than most of the other schools that I've really looked into, and certainly than any school that I've been to. And so we have this huge list of student organizations that students participate in that are affiliated with the Department of CAE. We've got anywhere between 350 and 400 students in our department at any given time. Right now we're about half grad, half undergrad, so it's not enormous, you know. Our incoming classes are usually 40 to 50 new first years, and then we usually get some transfer students from local community colleges and so forth that come in as well. And so the compilation of those not a huge number of students are really active in the American Society for Civil Engineers, the Construction Management Association of America, the Structural Engineers Association of Illinois, the American Society for Heating, Refrigeration, and Air Conditioning Engineers, ASHRAE, the Institute of Transportation Engineers, especially, and now most recently the Illinois Tech Railroad Club was rebooted a couple of years ago. Here's a picture of them making these model trains that they like take to shows and so on and so forth. They also have speaker events from the railroad industry every week. Chicago is a huge hub for rail, and it's a really works across disciplines. So this has been a super active club. ASCE has been our largest historically. And then we also, just to give you an idea of where and like kind of how our students spend their time, just this past week, a group of students created a new society for environmental engineers and scientists because they are interested in environmental engineering and they noticed that there wasn't really an existing club for them. And I think that is really indicative of like the typical Illinois Tech student, which is you're here to carve your own path and you're interested in your profession, you're interested in engaging in your profession and in your city and in your community. And so, you know, your path here is whatever you choose to make it. My goal as a department chair and as a faculty member here is to not get in your way, but to help you succeed at those. Some of these groups also, they all like to do tours and use the city of Chicago as kind of our background. Here's a tour of, for the ASCE crew, a tour of Navy Pier here in downtown Chicago a couple of years ago. Of course, a lot of these have been on hold, but that's changing very soon. So yeah, we get to use our city, you know, as our own playground, which is really fun. So I've got several slides on our great students because I just think that it shows you kind of who your peers will be and what opportunities are available. And again, I think I see that our students again punch above their weight for the size that we are. And so these are announced. So basically our students win scholarships pretty frequently. I just got 3 emails today about scholarship winners. This is from last cycle, the ASCE Illinois section. They award 12 scholarships per year, and we got 5 of them last year against all the other schools in Illinois, and they were spread all across construction, structural engineering, urban planning and development, and even environmental engineering or environmental water resources. So our students have won scholarships all over the place there. In ASHRAE, which is kind of the premier architectural engineering society for energy systems and buildings and so on. Two of our students won two of the four Illinois chapter scholarships last year. And I just learned this afternoon that both Sarah and Aluki have won again the same scholarship plus another student. So I think we've got 3 out of 4 this year, which is awesome. Um, our students are really active in competitions as well. So I showed you all of our faculty members kind of briefly in their as I went through our disciplines within CAE, or I showed their pictures and names. Those are all of our full-time faculty members. And then being here in Chicago, we also, in each one of our programs, we sort of dot our full-time faculty members with adjunct or part-time faculty who are mostly working professionals, a few of whom are retired from a long, history or a long career in whatever they did. And so those faculty members are absolutely invaluable resources to us, such that you have your fundamental courses taught, by full-time faculty for the most part. And then by the time you get into your elective courses, not always, but often we have this kind of pool of adjunct faculty that have worked in the industry for a long time. And so when you go to learn about how to apply structural design, or you learn how to apply construction planning, cost estimating, environmental engineering design for water or air systems, often you're kind of balancing both full-time faculty and industry type faculty who have done that for a long time. And so they're a wealth of information and resources and knowledge and everything. But they also, help you get jobs and stuff like that. So one of these, there's a story you can read online here. One of these is we have this construction and cost estimating class, which is very much mimicking like a real engineering and construction management firm, where you're basically given plans for a building. You take this in your senior year usually. You're given plans for a building, and you have to work with a group to like come up with a full cost estimate, like how much is it going to cost to build this building. And we recently sponsored with a company called Gordian, who makes cost estimating like software and databases, and they came down and they filmed our competitions, our final project competitions, for over like a 2.5-day period in this class. And then they actually contributed cash awards to those who performed the best. So it's not often that you get paid for doing good schoolwork, but it worked out that way. Speaking of competitions, I'll just mention another one because we just had a competition over this past weekend. I can't keep these slides updated fast enough. We've had in our architectural engineering area, led by Professor Eduarda Karate, who's both an engineer and an architect, so she speaks both languages. She has been leading teams who have competed with the annual Department of Energy Solar Decathlon Design Competition. The idea here is that the Department of Energy runs this annual competition where you pick a category you want to compete in: residential, commercial, high-rise, schools, mixed-use family, multifamily, etc. And then you work on a team to submit design, a full design document and narrative for a building on a site of your choice that is energy efficient and then has enough on-site renewables from like solar panels or whatever you choose, that it becomes a net zero energy building, meaning it produces as much energy as it uses on an annual basis. So very forward-looking kind of project. It's a design competition, not a build competition. So it's all kind of, in the office type work. And so she has led, 6 years in a row now. We've had teams that have competed and they've always made it to the final cut. Normally that would mean going to the National Renewable Energy Lab for the final day of competition. It's mostly a mix of graduate students, including coterminal students. Like David was a coterminal, accelerated master student. Erica, Alwilid, and Brianna were all in that as well. So sort of you would do this in your like senior to 5th year if you did an accelerated master's. So last year they did really well. It was held virtually, of course. We got first place for the first time in one of our divisions, this office building division. and then also got an honorable mention, a second place in another category. And then this year we submitted one team, uh, um, and the competition was just on Sunday. Well, it was actually kind of over the weekend, Friday through Sunday, and we won first place in our category again. We did a retail project. So again, the students who contribute here excel at what at what we do on a national, on a local, state, and national level, which is really awesome. This has become a real shining point for us. I'll also just mention a little bit of faculty highlights. We have lots of funded research. We have an Armour College of Engineering program for undergraduate research in engineering too, where you can actually get paid to get some research experience. And then sometimes research, paid or unpaid research opportunities just come up anyway if you're interested in an area. It doesn't mean you have to go get a PhD or anything. It's just, a great experience to get in your time here. So I'll just mention some of our latest research funding. We've really picked up the pace in this area in the last couple of years, especially with a couple of our newer hires. So Professor Matt Gombita just last year won over $1 million project from the Department of Energy's National Energy Technology Lab to essentially try to figure out how to recycle fly ash, which is a coal power plant product, byproduct, which we have just mounds of it sitting around. We don't know what to do with, how to recycle that into concrete. We were funded early last year, but the project's been on hold because of COVID reasons. We were funded with $1 million project, me and Professor Mohammed Haidir by the U.S. Department of Housing and Urban Development. We study energy and air quality and health from the built environment. And so we are going to be putting air cleaners to clean the air in the homes of military veterans who have chronic obstructive pulmonary disease. So they have COPD, like a lung condition. And so we're working, mostly ex-smokers, we're working with a physician, a lung doc at UIC, University of Illinois at Chicago, and also Elevate Energy, which is one of our greatest partners. Ann Evans is the CEO. It's a big nonprofit who calls himself a Think and Do Tank. So they do a lot of energy efficiency and environmental health type work. And again, being in the city, they're just wonderful collaborators for us. One of the reasons I've loved being here in Chicago. Our other funded research, we've got some, Professor Haidir has a project looking at the energy savings of like dynamic window shades in the Willis Tower, or you might know it as the Sears Tower. So he's down there every day or every other day these days working on this project, trying to evaluate like this kind of novel technology. We've also had some funding from a group called Franklin Energy, where we've designed and build these 3D printed like radiator controllers, so we can control heat output from radiators in old buildings like our campus. So Chicago and the Midwest is full of old buildings that are really energy efficient, and it's hard to make them more efficient. So this has been a cool area that we've adopted. I mentioned the Trimble Technology Lab. I don't know how public I can be with this number, but it's a big donation. It's like $17 million worth of hardware and software to form this lab, which will be coming online as early as this fall if we can get our construction going. And I'll also just mention on the environmental side, Dr. Dave Lampert, who just joined us in August. He's been doing some work on PFAS, which is kind of what's called a forever chemical. It's these sort of industrial chemicals that stick around in the environment for a long time. He's been doing some work funded by the EPA, working with a bunch of students across disciplines in both undergrad and grad to sort of cap sediments that have this compound or this set of compounds in them, and to try to prevent them from getting up into the water column and migrating through the ecosystem and so forth. I mentioned I studied energy and air quality in the built environment. This has been a really weird active year with people caring about respiratory virus transmission and indoor spaces and so on. So here's just a few stories. We published a paper a couple of months ago that was originally covered in the New York Times, actually, where we tried to model the progression of COVID-19 on the Diamond Princess cruise ship, which experienced this big outbreak of COVID-19 early on in January, February of 2020. And so me and a former PhD student of mine, Parham Azimi, he got his PhD at IIT. He's now a postdoc at the Harvard School of Public Health. He and I and our team built this kind of novel modeling framework to model the likely modes of disease transmission Was it through the air? Was it through surfaces? Or was it through droplet transmission, meaning just droplets that land right on your face? And we demonstrated the likely importance of aerosol transmission, which is why part of why a growing body of literature you're starting to see, double face masking recommendations and ventilation in buildings and that sort of thing. So we've had a direct impact there, which has been really wild. I'll mention just some of our facilities and resources. We've got these big structural labs. Even though we're a relatively small campus, we've got a relatively large space for structural materials testing. A lot of this is under renovation, much needed renovation. We've got a construction engineering and management lab. We've got a bunch of drone technologies for construction. We've got a sustainable transportation and an infrastructure research center, the STAIR Center, focus on transportation. We've got environmental engineering labs, some of which are under renovation. We just built a controlled environmental chamber that we're using daily these days as part of our built environment research labs. Again, focus on energy and air quality in the built environment. We've always got 1 or 2 undergrad students working in these spaces. If you're interested, I think that's another nice way to engage with us. IoT is small enough that we always have kind of an open door policy and you get to know your professors. And then we actually have 2 apartment units over in one of our graduate student housing complexes where we do all kinds of kind of neat testing over there. So, I just kind of want to give you a little bit of sense of who comes to CAE and who comes to the Armour College of Engineering and who comes to Illinois Tech. And I mentioned kind of the serious, or not the seriousness, but the professional and mature nature of our students. I mean, they have a lot of fun too, but I just think that people come here because they kind of know that they want to get a good job in their industry and do good for the world and their community. And so part of one of the things that makes us a little different in CAE is that we require a surveying class, and most of you will take that in your first year. In fact, your first fall. So you get out there with the vests and the equipment, and you're out using our campus to learn how to use surveying equipment. And we teach it and recommend it early in the curriculum because it means when you go back home, for your first summer, you could get an internship on a surveying team. You're not an engineer yet. You haven't had all your classes and everything, but you can start to get real life experience and make a little money. Here's a picture of the Intro to the Profession course, which I teach. It's like a two semester sequence of courses in your first year, doing an exercise where we challenge you to go make some estimations of our building using no tools, just your phones in your pocket and your bodies and so on. So it's always kind of a fun deal. We always do that when the weather's nice too. And then by the time you kind of get into your second year and then your third year, you get into more lab classes where you're learning about concrete design, construction materials, and so on. So here's just a picture of a bunch of people, much of students making concrete. I kind of like to say that your first and second years are in engineering are like your make or break year. You're either going to make it or you're not through some challenging physics and math classes and so on. But by the time you get to your junior year, it's like your make and break year. Like you get to make stuff and break stuff and learn how stuff fails and how you use that information in design. And then speaking of design and moving on into our 400 and 500 level senior and graduate level classes, then you start to really focus on really practical but fundamentally based things like building enclosure design, doing facade inspections of energy and structural performance. So you're mimicking sort of an engineering firm. And that's kind of the idea, right? To get you trained up as a professional engineer and on the path to pursue that career. And so I'll just leave it here with a zoomed in picture of happy faces at the Navy Pier tour. And just mention, that we also just spend a lot of our time with doing professional development and networking. And if you get involved with student organizations, it is your clearest pathway to learning about the industry, learning about jobs, and not just getting a good job, when you graduate, but like finding the right job that is the right fit for you and the right career path, and getting to know people who can make that happen for you here locally or abroad. So I'll leave it here and take any questions y'all might have. Welcome to the CAE department. I've got my email address here. You can ping me with any questions you might have. Can I answer any questions for anybody? Feel free to raise a hand, drop something in the chat. Mhm. Oh, I saw a direct message. Okay, thank you. Someone asked, is it possible to double major in civil and architectural engineering? That's a good question. And it is possible. I don't, I have like, I think one student right now that's doing it. Um, you know what I can do is show you our advising pages. So if you want to learn more about kind of what your career trajectory would look like here, I have some documents I could send your way, but you can find them on our advising tab. Um, and you can look at the two flowcharts for civil engineering and architectural engineering. So this is where you can always find our updated like curriculum flowcharts. Let's see. So this is civil engineering, this is architectural engineering. For your information, usually about 2/3 of our students are in civil engineering and about 1/3 are in architectural engineering. I don't really know how those numbers play out, but that tends to be about common. So there's a lot of overlap, but not perfect overlap. In fact, let me dump this in the chat so you guys have it. Yeah, good question. Yeah. Yeah, so maybe go explore those, but there's a lot of overlap but not perfect overlap, but it means that you could double major in maybe like an extra year, something like that. I don't usually advise it because you could instead spend that time doing a bachelor's in one and a master's in the other, and that carries more weight than a double major and takes about the same amount of time. So that's usually what I advise, although not everybody listens to me, that's okay. I know of one student who's doing a double major. Someone asked what percentage of students graduate in the 4 or 5-year accelerated master's programs. So the accelerated master's program is generally a 5-year total program. I'm seeing now about 20% of our undergraduate students are opting for an accelerated master's, maybe as high as 25%. So it's not a huge, but it's a chunk. It's a significant chunk. Can you do architecture and master in architectural engineering? You can. It's a little tricky, but I would say in architectural engineering in the master's program, something like 1/3 of our students come from architecture because they want to skill up. They want to get some technical skills. They'll probably never be a licensed professional engineer, but there's a lot of good jobs that you can get without that. And so that is certainly a pathway. Do we have a good architectural engineering program? I think that we do. I really love it here. And the fact that we have one of only about 25 programs. We are, what I see is that we compete with really, really well-known schools in this space who have had programs for a long time, like Penn State and Austin and Boulder and stuff like that. But we're the only one in Chicago, in the heart of the architecture, engineering, and construction industry. There's a group called ASHRAE, who some of you might be familiar with, the American Society for Heating, Refrigeration, and Air Conditioning Engineers. That is the key like architectural engineering society, especially for building energy and HVAC systems and so forth. To give you an idea of why I'm pointing here is they give what's called a new investigator award to one per year. They give $100,000 to um, to a professor who's doing like groundbreaking research in HVAC and building engineering and so forth. And from my knowledge, um, we're the only school um, with in the who has received uh, more than one of these in the last 5 years. So I won one in 2015, and then Professor Mohammed Najad won one in 2019. So I think even though we're small, like we're really strong because of our design program and our hands-on experiences and so forth, and also our active research areas. Um, okay. Oh, male to female ratio. That's a great question. Um, let me see if I can find this news story to show you. So in 2018, we achieved gender parity in our freshman or our first year incoming class. In 2018, we had that. I just happened to be teaching the freshman intro class, and I was like, a couple weeks into the semester, I was like, what? I feel like there's a really good balance here of genders. And we had 24 men and 24 women in the class. It goes up and down, kind of year to year. But it's not uncommon to see close to 50-50, actually 50-50, or, more commonly maybe 60% male, 40% female. That's pretty common. But we're pretty different from like mechanical engineering and electrical engineering in having usually a better gender ratios or more equal gender ratios. What percentage of your architectural engineering graphics who graduates who want jobs after a bachelor's and after a master's get jobs? That's a good question. The answer is pretty much everyone. The ones that don't get jobs that I can think of in the last few years are people who barely passed the program, who really, really got a 2.0 GPA or something like that. But across the board, placement's been more than 90%. What is the most typical route civil engineering students take? Like in your professional career? I would say in civil engineering and environmental engineering, you have probably a little, like maybe 40% will go into the public sector. 60% will go into the private sector. Your pathways are like a design only, construction, or consulting, where you kind of do a little bit of all of the above. And there's pretty like even distributions kind of across those. So some people go directly into like structural design, and they're really focused on just the design of structures or the design of mechanical systems or whatever. Consulting gives you a little bit more of like, hey, I don't know what's going to happen. A client might call tomorrow and we might be doing some forensics type of work. What happened in a failure? Or we might be doing some design reviews where we're asked to review design documents, or we might have to go do measurements in the field to see how a building is really performing and so on. So there's a lot of different paths. A benefit in getting a master's degree, someone asked. Well, usually, there's with a master's degree, you start with a higher salary, and you start with a little bit more knowledge, which is why you get a higher salary, a little bit more knowledge and a little bit more experience. And so that's why a lot of people do the like fast track accelerated masters, because it doesn't cost you a whole lot more, especially if you're already on a scholarship or financial aid. And then you can usually return a higher salary with a master's than with a bachelor's. That at a fundamental level, that's kind of the key issue. How do the civil engineering specialties work, like transportation, structure, and so on? So if you look at civil engineering, you get in your first. Oh, I saw someone ask too about make or break year. So what I mean by that is in our curriculum. Let's look at civil engineering first. Everything in orange here is like a civil engineering course or a CAE course. Everything is green is a kind of a core science course. And so what happens in engineering is that you're not gonna, if you're not super comfortable with math and physics, you're not gonna fail out because of a class on AutoCAD or learning how to do engineering drawing. That's not gonna be how you fail if you fail. it's going to be because physics was too much, or calculus 1 or calculus 2 or calculus 3 or differential equations was just too much. When you get into statics and mechanics of materials, if you don't speak the language, if it just doesn't work for you, that's when you're going to realize engineering is not for me, or it's going to be when you realize, hey, this isn't too bad. Engineering is for me. So that's what I mean by your first and second years can be really quite challenging. We try to sprinkle this in with like learning about why you're learning what you're doing, the introduction to the profession. We've got an earth and environmental science class that exposes you to sort of how the world works and where you fit in it. We have an engineering economics and statistics class, which is challenging, but it also helps you understand, again, business and making financial decisions and so on. It's these green classes and a couple of the orange ones that really trip you up if you're not ready. And then by the time you get in your third year, you're like, oh, I get it. I'm working with construction materials. I'm working with structural analysis. I'm working with structural design of concrete and steel. I'm learning about fluids and hydraulics. I'm starting to think more about my discipline rather than just, I need to learn calculus 2 and I'm not sure why. The thing is, you start to apply that. So say you've made it through differential equations. Well, by the time you get to fluids and hydraulics, you've already had statics, you have differential equations. You just start applying these. So then you get into your application years, if you want to call them that. You learn about transportation engineering, steel design, concrete design, construction estimating, geotech foundation. And you take electives in any number of areas like construction or environmental transportation. You can see these courses that we have on the books in our like undergraduate bulletin. It's just like a long list of courses. So I'll just randomly pick one. Boom, you could take railroad engineering and design as one of your electives and get it's a design course focused on railroads. And that would fulfill, boom, one of your tech electives. You could take, if you're in architectural engineering, you could take design of masonry and timber structures. We have a class on homeland security issues in engineering systems and buildings. We have a class on building energy conservation. Those all can count for your electives in like your junior and senior year towards your undergraduate degree. And then your master's, if you do it, is just like an extension of that. It's like more depth, more electives, and so on. So I think that answered 2 questions. Advantages of a 5-year program compared to a bachelor's. Essentially, again, kind of a return on investment type thing. Hopefully get paid a little bit more when you graduate with a master's. How many students participate in internships and co-ops? Good question. So we don't have a formal co-op program. People can do co-op, but because of our location in the city, a lot of people do internships both in the summers and then in their senior years, they're often doing internships, and even into their co-terminal master's year, if that's what they decide to do, they'll very often do internships. And what percentage? I don't have a good number on the percentage. It's not required, but gosh, of my advisees, the students that I advise, by the time they're in their senior year, something like a quarter or a third are like actively in internships, and then they get offers, from those companies or others, when they graduate. Will you get a lot of hands-on experience? Yeah, that's a good question. You guys are asking good questions. You do. You get hands-on in your first year when you take surveying. You're out there in the field, making measurements. You get hands-on experience in a chemistry lab, in physics lab. You get hands-on experience in engineering drawing, basically using your hand to learn how to visualize and draw engineering documents. And then AutoCAD, which is at the computer. So you're essentially doing 2D and then some 3D kind of rendering. So your hands-on experiences are both like getting your hands on objects in a lab, but then also sometimes in a computer lab or at home using your software remotely or at the library or whatever. In your third year, you have a computer lab structures course, which is like starting to learn software in the industry. So much is done on software now that's an important lab component. Construction materials is like learning how stuff breaks. um, Structural design 2 here, 307, is like concrete materials. So one of the things you do in that class is you make concrete, you pour a big beam and you break it in our big facilities. And then by the time you get in your design classes, you have a mix of hands-on experiences as well. I should also mention that we all culminate this in like a senior capstone experience. So we're actually trying something new this semester um, um, with our senior design experience, where we recruited a bunch of industry mentors. So people who are working in the industry, mostly here locally, in structural engineering, in construction engineering, in transportation engineering, and so on, mechanical engineering, electrical engineering for buildings. We've recruited them to basically give us their time and their staff members' time. So they have been working really closely as project mentors for our students in the senior design class. So it's sort of like an extension of the classroom, where in a non-COVID year, you could envision actually meeting, down at an engineering firm, downtown. We're like a 10-minute train ride from the heart of downtown. 2 miles, maybe 3 miles, maybe. So a short bike ride too. And so you can envision like working there and really learning like how an industry, how the industry does its job. And then with that really would come benefits of like getting to know professionals locally in the industry, which has myriad benefits. Summer internship opportunities for a civil engineer. Yeah, you start out early, you could do surveying. People, you could ask faculty about some of their internships. I had an internship where I was testing concrete. I wouldn't say I really liked it, but it's okay. It's okay to have an internship you don't like. Where I would sit on a job site and wait for concrete trucks to come in. And when they came in, I would go out with a wheelbarrow and I would capture this concrete, and then make these samples that we would take back to the lab and let cure for a week, and then let cure for a month, and then break it after a week and after a month, to make sure that essentially what they were pouring in the field was what the design expected. Because if they're delivering substandard concrete, the integrity of the whole design could vanish, right? If you're not up to par there. So there's lots of jobs like that, right? Soils lab testing, a lot of hands-on testing, which is not a bad way to spend the summer. Surveying is a great way to spend the summer. I had another internship where for a little bit we would go around and do like asbestos sampling. Like I remember it's like we would like break into abandoned buildings basically, and collect samples to see if there was asbestos or other issues in them. Send it off to a lab with the idea that like those buildings were going to be demolished for some construction project coming through, maybe a road or something, I forget. And they didn't want to release those materials. Like you have to clean up the site before you decide to do all that, or before you actually do the demolishing. So yeah, those are some. Water sampling, field sampling, all kinds of stuff like that. There's also like construction management type internships, and then early structural design. Like you could really start to get your hands on structural design. But the good thing is you can get out to construction sites and just kind of learn how things work. That's really, really good for people. I would say, part of that too is developing your oral and written communication skills. So throughout our curriculum, we've got spots where we make sure to emphasize those, because ultimately at the end of the day, when you talk to our graduates, the things that have set them apart are like professional networking and communication skills. Because for the most part, everyone can be technically skilled, but you can really set yourself apart there. So I know we're a tech school and like we're supposed to be, kind of historically, quiet and so on and so forth. But through our profession, and through our courses, we really try to emphasize learning those like softer skills, if you will. What got me interested in civil and architectural engineering? Hey, I'll tell you. You want to know the truth? I'll tell you the truth. When I went to school, I figured engineering was for me, just because math and science was pretty easy for me, and I liked it. I used to like to take things apart. I went into electrical engineering because I thought that I could make a ton of money there. That's what someone told me, a friend of my parents or something. I spent 2 weeks in electrical engineering and I hated it. I didn't understand it. You had to use imaginary numbers in all your analysis. It was really weird to me. I didn't really enjoy circuits and so forth. And I noticed that every time the professor would talk about voltage and current, they would describe it as like a reservoir of water and flow of water. And I was just like, I think I care more about the physical and built and natural environment than I do circuits. And in fact, he keeps talking about water. Maybe I should go study water. And that was kind of how I went to civil engineering. And I mentioned the concrete um, um, internship that I didn't really love, but that was okay. I had another internship when I got really more active in kind of an environmentalism and realizing the energy and climate impacts that buildings have through their energy use. And once I learned that buildings are the single greatest consumer of energy in the United States, more than cars and trucks and planes combined, more than all of our industry, I thought, wow, this is a place where I'm both interested. I've always loved buildings and how they work and want to learn more, but also could make a big impact on the climate and on the environment. And then as I went to grad school, I kind of learned about this intersection of energy and environment where, hey, we spend most of our time in buildings and outdoor air pollution becomes indoor pollution. There's a bunch of stuff that's emitted indoors from various pollutant sources, and that to me got to be really intriguing. So that's kind of how my sort of journey. Never did I really, you know, um, um, I just kind of followed my nose, if you will, right? Like pursued some experiences and opportunities, noted what I didn't like, and noted what I like, and followed what I like. How many students go overseas for work? That's a good question. I don't see a ton other than international students who start overseas to begin with and are like really familiar with international travel. The good thing is working in Chicago, we've got a ton of like multinational firms. Thank you, Alexa. No problem. Oh yeah, it's 5 o'clock. Okay, I'm sure we should go soon. Um, we've got a lot of large multinational things firms here in Chicago, and those have offices across the world. I think you have a lot of great opportunities to pursue that if you want to. Um, yeah.
All right. Well, thank you so much, Brent, for sharing all of this information, not just on the program, but also your own experiences. I'm sure that all of these students have kind of a lot to think about, and we found it very, very informative. For those of you who joined late, we will be sending out a recording of the entire session by email to all of you so that you will have an opportunity to review all the information. Just a few reminders, we do have a few other events coming up this week and next week. If you are still interested in learning more about Illinois Tech, there's actually a roommate mixer on Thursday if you're looking for a roommate and living on on-campus housing when you start attending here in the fall. And then we also have our decision deadline on May 1st. That is when we are asking all first year students or incoming first year students to make their decision on whether or not they want to attend Illinois Tech. But if you do have any questions specifically about financial aid or about enrollment, definitely reach out to your admission counselors. They are more than happy to make an appointment with you and discuss any questions you may have. But thank you again, Brent, for taking the time today to spend with us to really talk more about the Civil and Architectural Engineering program here at IIT. And I hope everyone enjoys the rest of your Tuesday evening and have a great night.